Good morning. In this lecture video, I'm going to explain Module 1, that is Semiconductor Diodes and its application. First, I'm going to explain the operation of Pn junction diodes. See, based on the electrical property of the materials are classified as uh, conductors, that means metals. Okay. So that allows electric current to pass through it. The best example is copper. Okay. And insulator does not allow electric current to pass through it. The best example is plastic or glass. Okay. And another one is semiconductors. Conductors, insulator, semiconductors. Semiconductor means electrical conductivity is between the conductor and insulator. Again, semiconductors are classified into pure semiconductor, that is intrinsic semiconductor, and impure semiconductor, that is extrinsic semiconductor, obtained by adding impurity atoms to the pure semiconductor. Again, extrinsic semiconductors, the process of adding impurity atoms is called doping. Again, they are classified into N-type semiconductor and P-type semiconductor. So N-type semiconductor is obtained by adding N-type impurity atom and P-type impurity atom to obtain P-type semiconductor. Let's see how do we obtain N-type and P-type semiconductors. So this is the N-type semiconductor. Means it is obtained by adding pentavalent atom. That means there are 5 electrons in the outer shell. That is antimony atom, showing 5 electrons in the outer shell. Okay, so among these 5 electrons, 4 electrons are shared with the nibrosilicon atoms to make a covalent bond, and this is the impurity atom. So we have 5 electrons in the outer shell, no? So 1 electron becomes free. So 4 electrons are get shared with the 4 silicon atoms, surrounding silicon atoms, and 1 electron becomes free. So this is N-type semiconductor. So N-type semiconductor, electrons are majority charge carriers. And similarly, by doping boron, that means trivalent atom. There are 3 electrons in the outer shell. If you add this into a silicon or germanium semiconductor, see, 3 are shared with the 3 nibrosilicon atoms. So one becomes free. One more electron is required. So it forms a wall. So this is what P-type semiconductor. So in P-type semiconductor, holes are majority charge carriers. So let's see. This is N-type semiconductor. These represent the holes, and these represent the negative acceptor ions. So when the electron is accepted, it becomes a negative ion. And here this represent the electrons, and this represent the positive ions. I mean, when the electrons is released, it becomes positive atoms, positive ion. So for N-type, obtained by adding pentavalent impurity atoms such as arsenic, antimony, phosphorus, etc. So current conduction is due to electrons. Hence, electrons are majority charge carriers and holes are minority charge carriers. And since donor impurity atom donates an electron, it becomes positive ion. And here P-type, obtained by adding trivalent impurity atoms such as aluminium, boron. So current conduction is due to holes, and here hence holes are majority charge carriers and electrons are minority charge carriers. So since acceptor impurity atom, it is an acceptor impurity atom, as accepted the electron, it becomes negative ion. Once the electron is accepted by the hole, it becomes negative ion. So using these N-type and P-type semiconductor, we form Pn junction diodes. Pn junction diodes. Okay. So diodes refers to electrode or two terminal device. So this is the symbol of Pn junction diode. So by combining P-type semiconductor and N-type semiconductor together, it becomes a Pn junction diode. Okay. So P-type, we connect one wire, that is called anode. To the N-type, we connect one wire, that is called cathode, and this is the diode symbol. So this direction R8 indicates conventional current flow. Okay. So it is a PN junction with connecting lead on each side. P-N junction diode means is a junction of P-type semiconductor and N-type semiconductor. So one-way device, that means it allows current to flow from anode to cathode under forward bias, and behaves as a open circuit under a reverse bias. So we'll discuss what is forward bias and reverse bias next. So diode is used as a switch. It is on during forward bias and it is off during reverse biased. That means this is the PN junction with the connecting copper lead connecting wire. Okay, this is the diode, PN junction diode. Okay, now we'll see types of diodes. So based on the current capacity and reverse voltage carrying capacity, there are three types of diodes. One is low current diodes. So current capacity is up to 100 milliamps and voltage capacity is up to 75 volt. And medium current diodes, current capacity is up to 400 milliamps and voltage capacity is up to 200 volt. And high current diodes are power diodes up to few amperes and voltage capacity is several hundred volts. Okay, these are the types of uh, diodes. Now we'll see operation of PN junction diode. So working principle. As you know, this is a PN junction, right? This is the P-type semiconductor and N-type semiconductor, and this is a junction. So before charge carrier diffuse across the junction, N-type and P-type metals are electrically neutral. That means these electrons are the majority charge carriers and holes are minority charge carriers in N-type, and holes are majority charge carriers and electrons are minority charge carriers in the P-type. Before they diffuse each other, okay, they are electrically neutral. When they start diffusion, see, holes are started to move towards the N-type because electrons are negative charge, they attract the positive charged ion particles, that means holes. Similarly, this positive charge attracts the negative charge, so electron starts moving towards the P-type and holes starts moving towards the N-type. This is called diffusion of charge carriers. This is called diffusion of charge carriers. When they diffuse, it forms a junction. That means here, yes, electrons are moving towards this, no? So these electrons are accepted by the holes since they are accepted, right? Since they are accepted. So when it accepts, it becomes a negative ion. See, negative ion, and then it forms a negative charge towards at the P-type, and as we know, holes are moving towards the P-type, sorry, N-type. Okay, so when holes are moves into the N-type, and this electron they combine with the electron, and electron releases the donates the electrons, uh, so it becomes a positive ion. When the electrons are released or donated, it becomes a positive ion. Then it forms a positive charge at the N-type, and this positive charge repels the holes to move further from P-type to N-type, and this negative charge, okay, repels electrons to move further from N-type to P-type. So this junction is called as a barrier potential. Okay? Barrier potential. Yeah, this means this is a depletion region. This region is called as depletion region. That means between immobile charges at the junction, there exist no charge carriers. Such region is called as depletion region or space of charge region. So it prevents further movement of electrons or holes across the junction. So on N side, it consists of donor impurity atoms, lost the free electron associated with them and become positively charged ions at the N side. Similarly, at the P side, it consists of acceptor impurity atom. It accepts the electrons, becomes negatively charged ions. By losing the holes associated with it, it becomes a negative charge. Clear? This is what depletion region. Okay. So let's see junction barrier voltage. At this junction, see at the junction, it has positive charge. towards the N type. It is positive charge and it is keep decreasing. It becomes a 0, and that means from here there is no potential barrier. Okay. And similarly at the P type, so it has maximum, so this is positive charge, and the P type it has maximum negative charge, and then it decreases and becomes a 0. It is a negative charge. Correct? So this positive charge attracts the holes. I mean negative charge towards the uh, P type is there, na? This negative charge attracts the holes, and this positive charge attracts the electrons. This positive charge at the N, N type attracts the electrons, and they are the majority charge carriers. As you know, electrons at the P type is minority charge carriers, and holes at the N type is minority charge carriers. So they are called minority charge carriers. But this electrons, repels the electrons at the N type and repels the holes at the P type. So they are majority charge carriers. So majority charge carriers are repulse and minority charge carriers are attracts. So even though there is a depletion region, a small current is flows. Okay. Now we'll see operation of Pn junction is divided into three categories under no bias or unbiased. Bias means applying external voltage, to reduce the depletion region or to vanish the depletion region. So under no bias, under forward bias, and under reverse bias. So thus we'll discuss in the next video. Thank you.